Hello, my name is Ekaterina Tumanova. I'm from Broadcom, Prague office, and today, together with my colleague Petr Klomfar, we are going to make a dive into the topic of mainframe performance on commit, and more specifically, conducting automated performance testing in continuous integration and continuous delivery pipelines for mainframe. Before we jump into a conversation about automated performance testing, I think it is essential that we talk about the current state of DevOps and how it applies to mainframe. So, where does this demand for automating everything into pipelines come from? Apart from being an industry standard for a non-mainframe world, it clearly has additional value for development and testing teams on mainframe. Let's talk about some constraints. We all know that traditional development tools for mainframe are not anymore providing the desired user experience for the new generation of developers. Specialists who are proficient with standard 3270 tooling are being harder and harder to find. In fact, we all know that many highly skilled mainframers are preparing for retirement, and people who are hired to replace them are coming from distributed background. In order to become proficient with the tooling, they have to go through a long learning curve. In fact, if we take an angle, for example, of the performance analysis, mastering performance analysis using COS standard tooling can take even years. But even if we take an example, for example, of Eclipse, Fed Eclipse clients have become sort of a standard for a part of mainframe tools, but it already is considered primitive by the new generation who comes out of the universities. They prefer open interfaces, web IDEs, quick scripting, quick creation of testing environments, something that they can quickly adjust to their particular needs. That is why open source tools are so popular around the world. DevOps concepts and open source tools are taking over the world hand in hand. Tools like Git, Jenkins, Visual Studio Code, open source tools are found everywhere. According to Gartner studies, 95% of the organizations leverage open source software in their mission critical IT workloads, whether they know about it or not. And this is statistics from 2016. So you can imagine that nowadays the numbers are even higher because every year open source software becomes the choice of more and more teams, and mainframe doesn't stand aside here. Let's go back to our topic and talk about a bit more about the situation with performance testing today and why we speak about performance testing on mainframe being part of DevOps. So what is the traditional approach to performance on mainframe? From our experience talking to our customers, we know that despite everyone understands that the more you test, the fewer are chances that the issue ends up in production, not everyone actually does enough performance testing. And even if they do, it's quite often a pre-production integration level testing where it is hard to find out what is exactly the cause of the issue. This leads to the situation when the issues are found in pre-production or production, and highly skilled specialists are required to deal with them. Of course, these specialists are hard to find, and they're always quite busy with other things, so it creates a bottleneck. Additional bottleneck occurs when these specialists have to communicate with development teams and advise them and discuss how to fix the problem. But it doesn't have to be this way, and many companies are starting to realize this, especially when performance tools receive new open interfaces. And performance testing becomes just one of the types of testing, which can be automated, scripted into the pipeline, and performed by the development teams themselves. That would remove the bottlenecks, which I mentioned, and according to the studies, reduce also the cost of defect resolution for the company by up to 64 times. Let's talk a bit more about personas who can make all this happen. And here we are talking about DevOps engineers and architects who would include the performance testing into the automated development pipeline, and developers and QAs who would actually perform this testing. Today, there are means to automatically detect performance degradation as part of automated pipeline on mainframe. And I'll talk about this in a second. And modern development solutions such as modern automation solutions such as Jenkins allow you, based on this detection, to immediately notify development teams. Furthermore, mainframe analysis tools nowadays also receive open interfaces, like, for example, Zowe command line. And this enables developers to not only be notified, but also allows them to do performance analysis using simple, familiar frameworks and interfaces. So let's think what happens if you don't do performance testing. In such case, as I said, mainframe teams wait weeks before finding the performance issue, and it not only has business impact, but also requires a lot of time from both production and development specialists. Moreover, there's actually higher chances that the issue will be introduced in the first place, because developer doesn't take performance of the code into account when she is making a change. They wait till it is communicated from the system management team. This is not a very effective practice, and in fact, experts suggest that you test performance early, and the performance is part of the development team's mindset. In such case, not only there are fewer chances that the issue will be introduced, but if the problem occurs, it is automatically found and easily addressed, because it is easier to trace back to the particular code change which introduced it. Let's look at the example of how you could achieve it. CA Mainframe Application Tuner, CA-MAT from Broadcom. It is a performance sampling tool which has extensive automation capabilities. It is used both in production for performance monitoring and in pre-production for performance testing. You also probably heard about Zowe, an open source framework which allows you to work with ZOS from off-platform, having cloud-like experience. So now CA-MAT provides two Zowe CLI extensions, command line plugins. CA-MAT Detect here on the left, which enables DevOps architects like Ravi to include detection of batch code performance degradation into the pipeline. Using CA-MAT Detect, Ravi can, after each commit, automatically check the performance metrics of the code and send them to the development team, and also notify development team if there is any issue, if the baseline for performance metrics was violated after the last change. So now developer, such as Michelle here on the right, is immediately notified whenever her commit has drastically changed the code performance. Furthermore, CA-MAT provides another Zowe plugin specifically for Michelle, so that she can not only be notified of the issue, but immediately start analyzing the application. So CA-MAT Analyze provides a set of commands and allowing Michelle to access detailed measurement analysis through the command line. She can use it in her, for example, IDE terminal. The great thing about these two plugins is that they actually work together. So whenever CA-MAT Detect reports an issue, CA-MAT Analyze already has measurement data ready, because the underlying component requests a measurement for every alerted issue. So Michelle doesn't have actually to rerun the test and reproduce. She can already jump to the performance analysis, because she has the data from the time when issue occurred. So here I would like to jump to the most interesting part, and I would pass over the screen to Petr, who will show us a live demonstration of how such pipeline with performance testing may look like. And Petr, this is all yours.
Good morning and good afternoon, everybody. My name is Petr Klomfar. I am product owner for CA Mainframe Application Tuner. Thank you, Kate, for handing the presentation over to me. Let me walk you through our implementation of functionality of performance on commit. So here is the diagram before we jump to the demo, to the actual demo. Here is the actual diagram of our implementation, and we will be focusing from the perspective of Michelle, who's the modern developer. She's going to update the code in ID of her choice. In our case, it will be Visual Studio Code. She will save it, she will stage it, she will commit it to her GitHub repository, and the change from the GitHub to the backend to the Endeavor will be propagated through integration with CA Endeavor Source Code Manager throughout the Enterprise Git Bridge solution. On the Endeavor, when the change appears in the source code manager, we have a webhook server listening to update action, but it can be any generate in place. It can be staging from dev to the QA environment, but in our case, it's update action, which triggers our CI/CD pipeline that is being orchestrated by Jenkins, and that is where CMET detect as part of performance on commit comes in place and collects the performance matrices. I will walk you through the details in the actual pipeline, but at this stage, Michelle can already use get performance commands or get alert commands to get some matrices directly from the CLI. But to make it easier for her, we actually provide emails. So performance report will be generated and sent to the Michelle. And in our case, we will focus on the alert in the dreadful situation that the performance degradation appeared. She will receive similar email like this. Let me walk you through in a minute during the demonstration. And this is also when the alert is generated where CMET analyze component is being kicked off and automatic measurement of the performance degradation or the program under test is being done. So she can then drill down into the details using the CLI commands respective to Mainframe Application Tuner, bring up, for example, the overview of the program, take a look on the history of the measurements, or she can drill down into the code view and CSEC section and inspect what is the issue and what's the culprit. Without any further ado, let me switch to the Visual Studio Code. Here we are, and I will make some change on behalf of Michelle. So, for example, I will change this subscript in the main line. I will save the change, as I said. I will then stage the change. When the stage is staged, I will commit it to a GitHub with the demo command, so we are transparent here. And whenever I am ready, I will push into the repository. This is where our pipeline will be triggered. So I can see passphrase, because security first. Okay, I can see that changes has been successfully pushed. Well done. Now let's switch to our CI/CD pipeline. I should see pipeline kicking up in any second. Yes, there is a pending pipeline. Whenever it kicks off, I will open it in the blue ocean because it's easier to observe. So when I'm in the blue ocean, this is how the internals of the pipeline looks. On the background, AutoGen job is being kicked off to generate the job in the source code manager. Then the actual application or the job is being submitted to the mainframe processing. Throughout that, PMA as a component of CMET detect collects the SMF records and compares them with the KSDS clusters for jobs and alerts for comparison, and then the summary report at the end is being sent out. When I'm looking at the email, what Michelle is going to be receiving, within the normal range is where everything is fine and we have a bright blue skies. We have these tiles. These tiles are CPU deviation, elapsed deviation, XCP deviation, and service unit deviation. They basically can have some variations dependent on the load of the machine where the job is submitted. Also in the email, we provide the performance test details for average values for the baseline or for the current versus previous run. And I should receive the email any second. Let me double check the Jenkins pipeline. Oh, there it was. So let me show it. And as you can see, the performance degradation was significant enough. So we have received an alert status. The alert status itself will be similar with the red tiles, and it's going to be providing the Zowe commands for Michelle to easily drill down. So we will jump directly to, for example, delay view. And if I just copy the Zowe command, go back to the terminal of my Visual Studio Code, and I will paste it, I should be able to bring out the display view of the CMET measurement. Yes, there it is. So I can see that the program active was 45% of the whole run of the application. So that's the one that I want to inspect the most. Let me just do advanced command Zowe monitor delay view addresses for this specific profile for the major and minor category of the program activity. If I press enter, I should receive the more granular information. And when I take a look here, it's a COBOL program. The statement in the COBOL program can span through the multiple offsets. So let's pick the one which is the heaviest. That's 9 delta 2. And I would be interested actually to see within the listing. So excuse me, I can also bring up the listing from another integration from Endeavor. So the listing should be coming in a second. There it is. And when I take a look into the assembler code, respectively, let's search for that 9 delta 2. So the 9 delta 2 was actually part of the instruction at. It was a ZAP in this case, but it was at instruction, as I can see, and that instruction was part of the subscript -100 label. So if I scroll up to the actual source code from the listing, I am looking for subscript -2, and this is exactly the perform that I have changed for 12,000 times, which is the main loop. So this is what caused the degradation, and this is basically the demonstration how user can bring up and utilize the value of the performance on commit functionality. Let me get back for my PowerPoint presentation still. Because if you happen to be a user of CMET, you can utilize these links to download these CLI integrations for CMET detect and analyze, straightforward. If you happen to be our customer or even observer from outside, we will be very happy to hear from you, your DevOps experience, your stories from the performance tuning, and you can reach out to us. We will gladly hear what you have to say, and please reach out to me as a product owner or to Kate as a product manager. We will be really happy to hear. Also, as a reminder, Broadcom is a partner on your DevOps journey. So we realize that your DevOps transformation can be challenging, and none of those, or there are now no two alike, I should say. But we are keen to work with you and help you to peel off the layers and to help you to disassemble the impediments that you may have on the road. And to demonstrate our commitment and partnership offerings, we offer these items that you can see on the screen for our loyal customers free of charge. So we would be able to help you with the design thinking, with the environment preparation, hands-on workshop, or even proof of concepts. So be sure to reach out to us. We'll be happy. And with that, basically, thank you for your attention and for your time being with us through the demo. And should you have any feedback or any questions, please fire them up.